So now I've got an absolute value that involves an inequality. So I'm going to write a sentence that explains what this is, describes what it is, and then I'm going to draw a picture. And from the picture, I'm going to be able to solve some inequalities. So here's what this means. The absolute value of x being greater than 5. Now the absolute value of x, here's what this means. The absolute value of x means this. The distance between x and 0 on the number line. That's how we describe this. The absolute value of x. Translated. It means the distance between some number x and 0 on the number line. And then I've got this symbol, greater than. So I'm going to write that is greater than. And then we've got a 5. So I'm going to say 5 units. So what I've done is I've just described in writing what this means. Now from this description, I'm going to draw a picture. And then from the picture, I'll be able to solve some inequalities. So here's what the picture looks like. Here's 0 on the number line. Now, where are the x's? Well, the description tells me where they are. The x's are greater than 5 units. So, and it's a strict inequality. So I'm going to write this. If I come out to the right 5 units, I have to go more than 5 units. So the x's are out here. And if I go to the left, I'd be at -5, and I'm more than 5 units. So I could be out here, right? If the x's are out here, if the x's are here, that x is more than 5 units away, all right? This is greater than 5 units away. Now all I have to do is just write what I see. What do I see right here? Well, the x's are to the left of -5, or the x's could be over here, and these x's are to the right of +5. Well, there's nothing to solve here. This is my solution. But I'm going to write it in interval form, so I'm going to write it like this. This goes, if you just look at the picture, this goes all the way down, keeps on going to -infinity. So it's going to be -infinity up to, but not including -5, so open parentheses, or we use this symbol here, that's a union sign, or, now what about these x's? These x's go 5 on, but not including 5, so open parentheses around 5 all the way to infinity. Now I'm going to solve this one the same way I solved number 6. I'm going to describe this in a sentence, then I'm going to draw a picture. And then from the picture, I can get a couple of inequalities that I can solve. So just this part right here, just this part right here, I'll do it in pieces. So that part right there means this. So this part right here, just this, translates like this. The distance, absolute value, so you think distance, the distance between this number inside and 0 on the number line. So I've got the distance between the number x plus 4 and 0 on the number line. Matter of fact, it always goes like this. It's like a template. The distance between the number and then whatever's inside there, you put that. So it's like a blank here. The distance between the number, fill this in, and 0 on the number line. Now this says, right here, this part is strictly less than, not less than or equal to, just strictly less than 3 units. There's my translation. Now draw a picture that matches this translation. Here's my number line, there's x, here's 0. Now where is this x plus 4? The x plus 4 has to be less than 3 units from 0. All right, so if I went out on the right, if I went out to 3, now it doesn't include 3, so open circle around 3. So x could be in here, because that's anywhere in here is less than 3 units. I mean, the x plus 4 could be anywhere in there. Or it could be, if I went to the left, I'd be out here at -3. And if I put x's anywhere in here, I'll be less than 3 units away from 0. So here's what I have. Just draw a picture that matches this. -3 is to the left of x plus 4, which is to the left of +3. Now, just isolate x by subtracting 4. All right, so I'm going to subtract 4. Now, -3 minus 4 is -7. Strictly less than x. Strictly less than 3 minus 4 is -1. All right, so here is the inequality form, but they want the answer written in interval form. So I'm going to go here. -7 and -1 are not included, so parentheses. -7 is the lower limit, -1 is the upper limit, and that is the interval form of our solution. It means if you pick any number in this interval right here, substitute it into here, you'll get and take the absolute value, you get a number less than 3. And we know how it translates. It's like a template. So here's the template. The distance between the number, fill it in, and that's always going to be in here. So you just write this template. The distance between the number, this number here, and 0 on the number line. Now this number that we're dealing with is this one, 2x plus 3, and 0 on the number line. Now here's what we have, is less than or equal to. Now how about if we write this? I'll write it like this, is less than or equal to. Now, couldn't you say that this is the same as this, is at most? Another way to say it. So you could say so far this, the distance between the number 2x plus 3 and 0 on the number line is at most, meaning is less than or equal to what? Right here, 19 units. There's our translation. Let's draw a picture. So here is our x number line. Here's 0, just mark as 0. And then locate this 2x plus 3. Well, where is it? Where is it on the number line? Well, I know. It is at most 19 units away from 0. So if I come out to the right, now it's less than or equal to. So I could come out and include 19. Now it's less than or equal to that, so it could be anywhere in here. Now if I went out to the left, I'd be over at -19, and it includes that. So if I'm anywhere in here, if you put that 2x plus 3 anywhere in here, it will be less than or equal to 19 units from 0. So we end up with this. Now just write what you see. -19 less than or equal to 2x plus 3 less than or equal to +19. All right, let's subtract 3 from both sides. So subtract that 3. So I'll do it up here at the top. -19 minus 3 is -22. That's going to be less than or equal to 2x. Less than or equal to 19 minus 3 is 16. Now we've got it in interval form here. No, we have it in inequality form. Right, this form right here, that's probably fine, but this is called inequality form, because I've got an inequality. This is inequality form, but the problem is asking us for interval form. So just write what you see. -22, comma, 16. The -22 is included, so square brackets. The 16 is included, so square brackets. So this right here, that's what we're looking for. That is the interval form. Now, here's what we could do. We could translate this, but look what we have. The absolute value, when you take the absolute value, this part here, this is always a positive number. And then you're saying that's less than, right? That's less than what? A negative number? Never. All right, that is not possible. So right away, you don't have to do any work here. You know that there is no solution to this problem. Now 10 is going to be similar to 9. Look at what we have here. This is a positive number, and then we're saying that it is greater than or equal to a negative number, -3. All right, now isn't that always true? All positive numbers are greater than or equal to all negative numbers. So number 9 was never true. This one is always true. All right, so we can, what we'll say is all numbers work, or we want an interval notation, so we'll go like this: -infinity to +infinity. And if I graph this way down here at the bottom, it would just look like this. If I even put a 0 here, x, it's just going to take up the whole line, right? I just darken up the whole line. And the last problem in this set is an equation. So I'm going to isolate that absolute value. Let's add 2. So we'll get the absolute value of x plus 5 is equal to 10. Now, I can just do this directly. I'll do this 2 ways. Here's what I could write. Take the absolute value off. X plus 5 equals plus or minus 10. Subtract 5. I'll get x equals negative 5 plus or minus 10. And now that tells me x is negative 5 plus 10 or negative 5 minus 10. So I'll get x equals, now negative 5 plus 10 is 5. Negative 5 minus 10 is negative 15. Okay? Now that's my equation form. Now I could do it like this also. I could write out the definition. I could describe what we have. So here's this part. I've described this part right here. Okay, I'm right over here, just to the left, this part right here. Okay, that says it's absolute value. So I say it's a template, right? The distance between the number, whatever's in here, template. Here's the template. The distance between the number, fill it in, and 0 on the number line. So our number is x plus 5. And 0 on the number line, and then what I've got here is an equal sign, is equal to 10 units. So if I draw a picture, here's 0. Where is this number x plus 5? Where is x plus 5? Well, it could be 10 units to the right, which would put me right over here, or it could be 10 units to the left, which would put me over here. So that x plus 5 could be here, the x plus 5 could be here. Now there's an equation, there's an equation, so I get this. X plus 5 equals negative 10, or x plus 5 equals positive 10. From this one, okay, I get x equals negative 5 minus 10, x equals negative 15, or I could get this one. X equals, just subtract the 5, x equals 5. All right, so there's our solutions. X equals negative 15 and 5. And that's exactly what we got when we just dropped the inequality sign, dropped the absolute value signs and wrote plus or minus.